Thanks for watching my video today. Let's try to prove the WALLI'S formula. Okay, so then is the integral from 0 to pi by 2 sine to the power n x dx and integral from 0 to pi by 2 cos x to the power n dx. Okay, actually these two are just the same thing where n is greater than or equal to 0. Now we have to recall back from reduction formula that I have already done. Then is the integral of sine x to the power n dx, which is minus sine x to the power n minus 1 cos x upon n plus n minus 1 upon n integral of sine x to the power n minus 2 dx. So this is what we have already done in the reduction formula of sine here, right? It is already there, so we are going to put from 0 to pi by 2, 0 to pi by 2, so 0 to pi by 2, 0 to pi by 2. Here if you put pi, sine pi by 2 is 1, okay, it is correct, but cos pi by 2 is just 0, right? So the meaning this whole time will be 0. When in is 0, sine 0 is 0, so all this thing will be 0. We are left with only this one, right? Therefore our integral I is nothing but n minus 1 upon n integral from 0 to pi by 2 sine to the power n minus 2 x dx, right? This is equal to, I just write here this one, right? Integral from 0 to pi by 2 sine to the n x dx is equal to n minus 1 upon n integral from 0 to pi by 2 sine to the power n minus 2x dx, and this is our integral, right, to be evaluated, so I just call it I. Now let me put this one to be equation 1. This is reverse, okay, it should be like this. This is equal to this. So now putting n minus 2 in place of n in equation 1, we have that what, in place of n you have to substitute n minus 2. So it will be integral from 0 to pi by 2, right? Integral from 0 to pi by 2 sine of, in place of n, it will be n minus 2, sine of n minus 2x dx, because we need this one, right? Sine n minus 2, so n minus 2 is equal to, if you put here n minus 2 in place of n, so n minus 2 minus 1, which is n minus 3, and this is n minus 2, and integral from 0 to pi by 2 sine of, if you put here n to be n minus 2, so n minus 2 minus 2, which means n minus 4, right, x dx. So if you put again in this one, we are going to find out this one, right? So if you put in place of n here in equation 1, put n equal to n minus 4, so you will get integral from 0 to pi by 2, this one, sine of n minus 4x dx is, if you put here n minus 4, right, this will be n minus 5 by n minus 4, right? Integral from 0 to pi by 2 sine of n minus 6x dx. Now if you continue it this way, okay, or from 1 we get that what, integral from 0 to pi by 2 sine n x dx is nothing but n minus 1 by n integral from 0 to pi by 2 sine n minus 2x dx. This integral is again equal to this part, right? So which is n minus 1, n minus 3 by n minus 2. Again this part is again equal to this one, right? So n minus 5 by n minus 4 integral from 0 to pi by 2 sine n minus 6x dx. So from these three equations, if you see carefully, if you look carefully, then there is a pattern, right? So there's pattern. Now if this keep going on, okay, n minus 6, n minus 8, n minus 10, n minus 12, and so on, keep going on. Now here two cases arises, okay, two cases will be, it can be arises two cases. Then is whether n is even or odd, right? That is the case. Now case 1, when n is odd, right? When n is odd, meaning integral of sine x dx, this is n is odd, right? This is 1, and or sine of cube x dx, right? So this is odd. When n is odd, what will happen to our integral? So our last integral will be, this will keep going on for this will keep going on, right? N minus 6, n minus 8, n minus 10, and so on, it will go on until unless it comes to, right, n, this will keep going on and until unless it comes to n, right, n. So when n is odd, so if you put here n to be odd, then the last term will be sine x dx, right? because odd terms is start from 1, right? So when n is odd, so it will start from 1. So meaning if you put here 5, right? 5 is odd number, right? Or if you put here sign to be 1, n to be 1, then n is odd. Or if you substitute here n is equal to, wait, here if you substitute n equal to 3, right? Or here n equal to 5, right? No, n equal to 7 here, and here n is equal to 5, right? So in all this case, the last term will be sin x dx, that means power 1, which is odd, right? So now this integrate this one, so you get minus cos x integral from 0 to pi by 2, which is equal to 1. So continue this process here, right? Now the case 1 is when n is odd. Hence when n is odd, from equation for this one, what do we have? We have the integral from 0 to pi by 2 sin nx dx is n minus 1, n minus 3, n minus 5, and so on up to when n is odd, right? So this when n is 7, right? It means when n is 7. Example like here, when n is 3 or 7, when n is odd, you get n minus 1, n minus 3, n minus 5, and so on up to 642 upon n minus 2, n minus 4, and so on up to 531, right? So which is 0 to pi by 2, and the last term is sin x dx. So sin x dx is just 1. So when n is odd, integral from 0 to pi by 2 sin nx dx is n minus 1, n minus 3, n minus 5, and so on up to 642 upon n minus 2, n minus 4, and so on up to 531, right? It decreases. It's something like a factorial, okay? So this is when n is odd. Now when n is even, what will have happen? So if you see if you look at equation 4, when n is even, right? Something like when n is sine square or sine 4, right? When n is even, so this will be what? Here, if you put here in place of here 6, so 6 minus 6, 0. So the last term will be just sine to the power 0, right? Because 0 is even. So which is integral from 0 to pi by 2 dx, which is x, 0 to pi by 2, which is pi by 2. Therefore, from equation 4, when n is even, what do we have? What do we have? Sine to the pi by 2 sin x, integral from 0 to pi by 2 sin nx dx will be what? N minus 1, n minus 2, n minus 5, and so on up to 531 upon n minus 2, n minus 4, and so on up to 642, and integral from 0 to pi by 2 sin 0 x dx, meaning the last term will be 0, right? If you see this one, it keep decreasing, right? It will keep decreasing, so it decreases, so that the last term will be 0 when n is even. So then you will get integral from 0 to pi by 2 sin nx dx, which is n minus 1, n minus 3, n minus 4, and so on up to 531 upon n minus 2, n minus 4, and so on up to 642, and this is nothing but pi by 2, right? So here you can say that in short we can say that when for this integral, when n is even, when n is odd, then it will be n minus 1, n minus 3, n minus 5, and so on 642 up to n minus 2, n minus 1, and so on 531, right? When n is even, so it will be pi by 2 with pi by 2. Here y is 642, y2 is the last term, right? So let's take when n is, let's see 3, right? 3 is odd number, so when n is 3, 3 minus 1 will be 2, right? This 3 minus 3, this cannot be taken, okay? Because if you take this, the whole term will be 0. That's why neglect this. So this will be 3, so 3 minus 1 will be 2, right? And here also, if finish, so the last term will be 1, right? 1 will be 1. If finish 3, 3 minus 2 will be what? 1, right? So it will be 1 and 3 and so on. It keep decreasing, okay? So note that integral from 0 to pi by 2 sin nx dx is equal to integral from 0 to pi by 2 cos nx dx. These two are same thing. So this is the Wallis formula for sine, okay, sine and cos.